Thanks. Hi everyone. I don't even know if it's actually working last minute. Welcome to my talk. M&Ms Your Way built a fun Flutter-Powered candy dispenser with live treats on the Raspberry Pi 5. Even though this talk is only about 30 to 35 minutes long, we do have a short agenda. First, I'll talk a little about me, very brief. Second, I will talk about the hardware being used in this project. You can see it already right here. Then I will explain to you how to set up Flutter to develop on embedded devices in general. Last but not least, we will go through the steps to create this particular machine and to get started with embedded Flutter. So, about me. Hi, my name is Moritz. I'm a GDE for Flutter and Dart. I'm one of the founders of SnapX, which is a Munich-based Flutter agency, and I'm also one of the organizers for Flutter Munich. So if you have any questions regarding the company or the meetup in Munich, if you want to do collaborations, give a talk or whatever, also if it's about the company, just feel free to reach out to me. LinkedIn, Twitter, X, wherever, yeah, it shouldn't be too hard, or just come to me here and speak to me. So, enough about me, let's talk hardware. Well, yeah, that looks promising, but that's what we have here right now. Let us go through that one by one. The hardware we're using in this project to build our candy dispenser with M&Ms. First, we have a Raspberry Pi 5. This one is with 4 gigs of RAM, 8 gigs of RAM would also work, with the SD card in it, with the Raspberry Pi operating system on it. As you'll now have the chance to see, you can come forward afterwards and see the performance of the 4 gig model. You'll realize that it's fine, because this is a question I get asked a lot of times, is the 4 gigs or 8 gigs, what should I use? You can see here firsthand, 4 gigs Raspberry Pi is already so powerful, it's really fine for most of your Flutter applications. Also Raspberry Pi 4, we'll come to that topic later, will also work just fine. Next, of course, we have a 10-inch display. I think this is even 11-inch because a 10-inch display broke. Yeah, I sat on it by accident. Yeah, it really happened. Yeah, it's a waveshare display, not much to say about it though. The thing is, we used different displays in different sizes over the last year or it's 2 years now with different embedded Flutter projects. What I can just tell you is that we never had any problems with waveshare displays. They have a great viewing angle, great panel. I don't know if if other displays are better or worse. I can just tell you if you want to get started, this is a good start. You get them on Amazon everywhere. Touch just works out of the box. That could be an issue. So yeah. Obviously, we need some kind of dispenser. I'm not going to tell you where I found that one. What is important about this one is the material mix. I think this is unique with 50% plastic, 40% plastic, and 10% plastic. I don't know if this project would work with other material mixes. Yeah, to try out. And yeah, then we have the servo controller board. It's a PCA 9685, I think by Adafruit, yeah. So this PCB basically translates between the Raspberry Pi and our servo motor. And yeah, so basically we could drive the servo directly from our Raspberry Pi. But the thing is, a servo motor like this needs a little bit more current, so that could limit our Raspberry Pi. And by using one of those boards, first we have the option to use up to 16 channels, 16 servos at the same time. And we're connecting this board with a digital bus to the Raspberry Pi. The good thing is, boards like this come with a library that we can just use that's delivered by the board manufacturer, and that comes very handy. You'll learn more about that later. Last but not least, we have the servo motor with continuous rotation. That just means there's generally 2 different types of servo motors. One that just drive from an angle to another angle, like minus 180 to plus 180 degrees, giving the lowest signal minus 180 or minus 90 degrees, highest signal plus 180 degrees. And there's continuous rotation servos. For this project, obviously, we want one that rotates and gets us the M&Ms through this thing. So we have the continuous rotation servo. So now we have all of the parts. We just need something to attach it to another and have the servo attached to the dispenser. And therefore, if it works, maybe. Yeah, so what we need is something to hold the serial dispenser, attach the servo to it, and therefore we can just use Autodesk Fusion. It's a pretty good CAD program and it's free for private use. It also works on Mac. That wasn't the case when I learned that in university like 10 years or 15 years ago. And then we design the stuff we need and we print it with a Bambu Lab A1S printer with PLA. And yeah, here's just real short video of how that looks. And yeah, what you'll see now was, I think, one of the first prototypes for this machine. It was bigger then. Nearly done. Yeah, that's it. That was the first prototype of the machine right here. So now we have all we need. We can get to the topic I guess you're here about now. You learned a lot of stuff you didn't come here to learn. Let's talk about the embedded Flutter setup. And let's start and put Flutter on our Raspberry Pi. Wait, why are there now different options of Flutter? Why don't we just run a Flutter application on the Raspberry Pi? I don't know if you've heard about this. There's Flutter, Flutter-Pi, Flutter eLinux, and IVI home screen. Isn't all of this Flutter? Well, it is. But to work on different platforms, Flutter uses the so-called embedders. And if we run Flutter on iOS or web, we just normally use the official embedders that come shipped with Flutter. These connect the Flutter application with the target system where it is running on. But besides that, there's also the option of using custom embedders for devices that are not yet officially supported or included. And exactly that is what Flutter-Pi, Flutter eLinux, and IVI home screen are. So if we look at the options we have, if we want to run Flutter on a Raspberry Pi, we'll see that it's always Flutter. One time with the official Linux embedder and 3 other ways with custom embedders. And you may ask yourself now, why do we need this? And now comes the bad theoretical Linux world part, but I just want to give you a briefing of why we need it. And to understand that, we have to look at the components that play a role on an embedded Linux system when we want to show a Flutter application. First, of course, we have the GPU, followed by the GPU driver. They connect to the graphics API, such as OpenGL or Vulkan, which connects to the operating system through to the display server protocol. We have graphics toolkit and libraries, such as GTK and GTK. Finally, our Flutter embedder. You don't need to understand all of this, but I want to explain you how you have to decide what embedder you should use for a different target setup, just by a few examples now. I hope that it's an easy way of showing this. So example 1 would be using a NXP IMX8 microcontroller. And this now is really, if you were to order a fridge next week with a touch screen on it, I think there's some fridges with touch screens now on it out there, and you get that, chances are pretty high that there's a IMX8 microcontroller running on that, and even that there's Flutter running already on that, and we don't even know it. So this microcontroller is really widely used right now, also for applications that come out in the next years. And we have a custom Linux build in the embedded world. That's very often the case because we really only want the components, even for the operating system that we want. So we craft our very own tailored Linux version every time with Yocto or Buildroot. And here we don't have any graphic toolkit or library, so no GTK or GDK available. And that's a very big thing because Flutter Linux needs those. Those libraries are normally used, they do a lot of stuff. They do like toolkits like tabs and so on when you have them in Windows. Those come through GTK and GDK. Of course, we don't need those in an embedded Flutter application. Like on your fridge, you just build one application. You don't need to switch between applications. But the thing is, you can't just leave it out because Flutter uses GTK and GDK also to connect to the kernel in some ways, so we can't use the Flutter Linux embedder anymore with this. Here, a very good fit would be using IVI home screen, which is mainly developed by Toyota, because it works great on a system using this display server protocol, Wayland, GTK and GDK. You may not know these things, but that's what you have to look up and then go into in those embedders, go into READMEs, and there you'll find documentation. Is it working with this? Is it working with this? You just have to go through that. Example 2, we're using a NVIDIA Jetson Nano with another custom Yocto build. I'm not going to take so much time this time. No GTK, no GDK on the system. Even no display server protocol. We have here what's called direct rendering management. If you just Google and look direct rendering management, no GTK, GDK, you'll directly find, hey, Flutter-Pi is the way you should go. Example 3, which is the most interesting one for you here, I guess, would be with a Raspberry Pi 5 with Raspberry Pi OS. There we have GTK and GDK free. We use Wayland as display server protocol. The competitor Xorg would also be available. Therefore, we can just go with the standard Flutter Linux embedder. So, in conclusion, to decide which embedder you should use for your embedded Flutter application, you need to find out what the target system is. Not only software, but the composition of software and hardware. And then there's a few questions like, is GTK, GDK free available? Just go with Flutter, it's fine. Do you have no display server protocol at all? Flutter-Pi, I would try that first. Vulkan instead of OpenGLES, IVI home screen Toyota. That's the situation right now. Maybe that will change in the future, that we can just use one embedder for all of this. Maybe it'll be a embedder included in Flutter directly, but that's how it is right now. When you know that your requirements are met, you just try it out on the device. You see, is it fast enough? Do I have chunk? Just try it for yourself. Maybe even if it works with Flutter, for the beginning it's fine, but maybe try Flutter-Pi and see if you get more reserves in terms of performance. But TLDR for Raspberry 4, Raspberry Pi 4, 4B and 5 with Raspberry Pi OS, you can go with standard Flutter. You can just follow the instructions on the Flutter homepage for Linux. It will work just fine. So, back to our original question. For our use case, we could go with option 1, but we will use Flutter-Pi instead because the performance is even better. So, let's see how we can set that up. Now we're getting finally to the real interesting part, how we actually develop our Flutter app on our Raspberry Pi. So first thing, our development setup, how should that look like? I mean, we have two possibilities. I guess you know it. We have a Raspberry Pi that runs Linux. We can plug in a mouse, a keyboard, display. We can install VS Code on there, Flutter with all dependencies, or Flutter-Pi, everything. We can just develop on the Raspberry Pi as if it were our computer. Or we continue developing on our normal machine, on our normal Flutter development machine, our environment, and somehow connect the Raspberry Pi to it just like we would do with a mobile phone, iOS or Android. I mean, normally we develop on our computer and then we can just select it as a debugging device. So yeah, that would be cool. Let's compare those two. If we compare them, then we can clearly see that both would get the job done. But one of those approaches is just so bad to work with because you'll have two keyboards, two mouses on your desk. And then you're doing something in a Raspberry Pi and then you don't have the application for it on there and then you're typing on your computer and then you mess it up. Then you type on the keyboard and it's the wrong keyboard and it's not cool. So let's take a look how we can start developing on our development machine, the normal development machine or laptop we use. What requirements are we facing here? So first and foremost, we need Flutter and some IDE on our normal dev machine, but I guess we all have that here because it's a Flutter conference, and I guess all of you have been developing with Flutter. Then we'll have to install all the dependencies for Flutter on the Pi and of course Flutter itself. Last but not least, we have to somehow connect the Pi with our development machine so that we can debug with it. So let's go through that step by step what we have to do. Step 1 is to install snap CLI from pubdev. Step 2, run the bootstrap command, and step 3, you're done. It's not that hard, so I'm actually not kidding. So just a second before I start the video. What happened is that we had to do this task over and over again. We're working on different projects for the Raspberry Pi with Flutter. And then we created some scripts. Out of those scripts, we created some more scripts. At some point, we created a command line interface for it. And at some point, we were like, hey, why not open source it? And that's what we did. And all you have to do is to install the tool via pub.dev on your normal development machine and have the Raspberry Pi on and running in the same network. And you won't even need to plug in a keyboard or a mouse during this whole setup while developing with your Raspberry Pi. It just works from your normal development machine. So you go on pubdev. We have more likes. I think we now have 12. It's not longer 11. You install it. Select which device you want to set up. You run the bootstrap command. You select which device you want to set up, and then enter its IP address, followed by the username and the password you set in the beginning for the Pi, and whether you want to use original Flutter Linux or Flutter Pi. And then grab a coffee and wait. The tool will install everything. And this video now is really, speed up a bit. Drink 2 coffees or so. It's 15 minutes depending on your internet connection, on your bandwidth. It just needs some time, but I think you know that from setting up Flutter initially. Now, what's really cool about Snap CLI is, and of course this is just an open source tool. We called it with our company name, but we're not selling anything here. That would be really awkward. Now what's really cool about this tool is it'll also register your Raspberry Pi as a custom debugging device for you. That means that just like you're used to do it with mobile phones, you can select the Raspberry Pi as a debugging device in your IDE. So you can see it here on my laptop. It's actually remote debugging with the Raspberry Pi right now. I hope it's still running. I can't see it from up here. But here you can see we just finished it. We created a new Flutter project. We go in there and you can even see it already on the bottom right. I'll make the fonts a little bigger in a second. We can now select Raspberry Pi as a debugging device, and we hit run and it'll run with DevTools, everything available, just out of the box. So when you want to compare, when you want to see, is it fast enough, is it working, you have DevTools here, you have hot reload. It's really easy to see if you have jank, if you have anything. You can see it here. It was hard managing 2 videos at the same time, but the counter starts and it's interactive. You can see it live here after the talk. Just come forward. It's running. It's still running. Yeah, it's running right now. So development setup, check. Now that we know how we can set up Flutter on our development machine, on the Raspberry Pi, how we connect all of this, let's talk about the actual application. Like, how do we get a servo controller turning something out of our Flutter application? So now let's see how we do that. Here we have, to have a better understanding, we have this very detailed architecture diagram of what we want to do. We have a Flutter application that talks to the Raspberry Pi, which then talks to the servo controller, which then sends a signal to then turn the servo, which gives us candy. That's what we want. So on software side, how do we control the servo? What possibilities do we have here? We have several options. And First thing, a lot of you maybe think about this. First, we could create a Dart plugin, use the data sheet, all the specifications of this PCB, of the servo controller, and to write our own application and implementation of how we connect through the GPIO boards. We don't need to implement this. There's a Raspberry Pi GPIO package on PubDev, but then we could implement the commands, so the zeros and ones we need to send to this board to initialize it and to turn the servos. We could all implement that by ourselves. Yeah, option number one. Second, we could use FFI to connect a existing C or Python library, which controls the servo to our application, but just keep in mind that debugging through FFI is really no fun. There's no stack trace or things like that. So I would rather use FFI when you really have real big benefit from it. Like there are some libraries, there are things where FFI is great and it's just so much faster to use it, but debugging and getting there is actually not that easy, and you should just know that the other side of the equation works. So to the third option, we could start a MQTT broker, of course, local MQTT broker. We started on the Pi. We can use the MQTT package that's on pub.dev for our Flutter application, connect it there, and on the other side maybe use some Python or C script or whatever we want to listen on the MQTT broker for signals and rotate the servo on Python side or whatever when we want to do that. Fourth, we could create a local REST API instead of the MQTT broker. More or less the second approach. We can use whatever technology we want there. Or the fifth option, we could use dbus, which is already running on the Raspberry Pi OS and most other Unix systems, to do that job. And for those of you who don't know it, I guess most, dbus is an inter-process communication system that allows multiple software applications to talk with each other on your Linux system. So it's used extensively on Unix systems. And one example would be when you have your desktop system and new hardware is plugged in, like a new, we don't use USB sticks anymore, but back then, a few years ago, you would plug in a USB stick and then a small window would pop up, hey, you connected some hardware. That could very well be an example of dbus in action on your Linux system, because the hardware controller would check all the time, is there new hardware, is there new hardware? Finally, yes, there is new hardware, send out a message on the dbus. Then we have like a desktop daemon or some daemon that listens there and then shows us in another application, some hardware was just plugged in. So what we could do with dbus is we could write a script in Python, C or whatever, or use some scripts that already exist and connect them to the bus from the other side. From our Flutter application, we could use the dbus package that's already on PubDev and connect and send messages on the dbus. Last but not least, we could use one of the numerous other inter-process communication tools to achieve that. If we were, Toyota is doing it, they're running Flutter on the car, and maybe if you do some action there, dbus would be too slow, too much overhead. It's really not for most of the use cases, but let's just assume you have something special in the car. Then there's other ways, other inter-process communication models and ways to achieve this. I don't want to go in all of them there. There's more ways, I just want you to know that. For this project, we're going with option number 4, and I'm going to tell you why. Let's look a little bit closer into that. So what we want to achieve is something that looks like this. As dbus is already used on Raspberry Pi OS, we can just hook onto that. What we therefore need to create by ourselves is a dbus client for our Flutter application and a Python script, you'll find out why we use Python here, that drives the servo and connects also to the dbus. So for our PCA 9685 board, just as for a lot of other sensors and motors, actuators in the maker world, there are ready-made libraries and examples written in Python. You will find so many example projects. You will find a lot of code that's already working that we can use. So what we want to do is basically we want to use one of those example Python projects and connect it to the dbus. So what we basically want to do, we go online, we search around, we find a Python example project and we mix it with a dbus example project. So we copy and paste the shit out of it and then we hopefully end up with something that is working. Just like we learn programming. I don't know, there's people who read books and so on. I don't do that. I copy and paste and then debug. That's, yeah, how I learned it. So here's a little bit of code actually how all of that works. And of course, you don't have to remember the code now. There's the repository is open. I'll share a QR code afterwards. You can check it out if you're really interested. You can build it at home. Everything is there. So all we need to know is we need to enter some information needed for the dbus here. So for example, that we're using the session bus. There's two options, session bus, system bus. System bus is the one we don't want to touch. There's important stuff going on. We can't just access it so easy. Session bus is the one we want to go with. We give it a name and so on. We have to do some things in here. We have to initialize our I2C bus for PCA 9685. We go on, I just got the sign that I need to speed up a little bit, so it's going now faster. Yeah, we do all this, you see it, we initialize it, we set the frequency, that's basically that example project. We finally create a method in Python that is then available on the dbus. So here it's called throttle motor, it takes the ID because we could connect up to 16 servos and it takes the duration and the speed and that's it on the Python side. On the Flutter side, or to be precise on the Dart side, the implementation is even simpler because we use the dbus package which is maintained by Canonical to connect to the session bus and call the method we just exposed in the Python script. That is why I want to show you this approach. You could use that for all the sensors, all the maker projects you can find out there with Raspberry Pi, Raspberry Pi OS. It's really not that hard. Check this out, follow along, and it'll work. So let's look into how this looks on the Dart side. In the beginning, you can really just use a Dart script. So in Dart, we use the dbus package, and we just enter the information we just entered in a Python side as well, like the name of our dbus instance, blah, blah. And next, we create a function called throttle motor. And you will see here we have some syntax to follow, like a signature, what comes in, what arguments go in, and so on and so forth. And that's already it. So we're controlling the servo from our Flutter app through dbus and our Python script. So all that's left to do is to build some fancy UI around the function that is triggering the servo. That's what we did here. And as I think this is the rather boring part for a Flutter developer and for this whole presentation, let's skip that, use the time to test the working machine. It's broken, in fact. It didn't live through the flight. I just figured out, sorry, but still there's M&Ms, and I'll show you what broke. But let's use the time for some questions and answers. And you can still come and interact with it, and you can see how the reaction of the Flutter application is. If you want the source code, here it is. If you have any questions, please feel free to come forward. Thank you very much for listening.